Hello, everyone. OK, so I want to be able today to give you some reasons to check out Rust, and I'm going to do that really quickly. So let's get on with it. Brace yourselves. So what is Rust? Rust is a systems programming language. It sits in the ecosystem right along C and C++, and it's actually designed to do the kind of things that C and C++ are traditionally used to do, making web browser engines, web servers, language compilers, and all of that kinds of things. And in fact, it was created by Mozilla because they actually wanted a language to build their new browser layout engine, Servo, in. Now, I'm an application developer. I don't write operating systems. I write things for end users. And to me, system languages have always seemed arcane. There's this high barrier to entry that exists there. I'm used to coding in JavaScript, in Ruby, in Scala, and all of these languages, they give me they allow me the ability not to worry about a lot of things that you would typically have to worry about in C++. They have a garbage collector, which clears up my memory for me. They've got big run times that give me lots and lots of facilities that you just have to work out yourself when you're using C and C++. However, low-level languages like C and C++ are really, really useful, even if you are creating primarily user-facing applications. There's a whole host of uses I've found in the past. You can use them only to work with low-level libraries. You can't tend to do this kind of thing with a higher-level language, but if you want to implement interfaces to custom hardware and so on, you typically drop down to the sort of C level. A big thing that I've found in the past is optimization of hot code paths. One thing that happened at Twitter when I worked on the web team is that the Ruby implementation of Mustache was actually taking a really large amount of Twitter.com's request time. My colleague Rob, who was the one person in our team that could write C, actually re-implemented the templating language, the Mustache renderer inside of C. It actually completely slashed our request times. But then it left us with only a limited number of people that knew how to work with that code base. Another great thing you can do is interface with Apache, Nginx, and lots of other things that can consume modules written in C and C++. It's really good for light services. A company called Tilda have a performance monitoring software, and their sort of very light user agent that sits inside Ruby and Rails applications and reports performance data was all written in Rust, and it's one of the first sort of production deployments there. The problem with these low-level languages, as well as being arcane, because they force us to work with memory and think about how we allocate memory and how we think about concurrency on a really low level, it's absolutely rife with footguns. There are millions and millions of ways in C and C++ that you can really, really trash your systems, and you need to be really, really careful. So, to summarize, C and C++, they're fast. They're as fast as you can get without going to machine code directly, but even then, they're probably faster because a C compiler is optimized more than a human. They give you more control. They give you pretty much all the control you can possibly get over a system, but they have a lot less safety. In fact, they have nearly no safety. Now, the reason that Rust is really interesting is that it's still just as fast as C. They say it's comparatively fast. It relies on abstractions that are actually only used at compile time, which means the actual resulting compile code is as fast as it can be. It still gives you all of that control. You still get that low-level control, but it actually introduces safe handling of memory. So you're not going to get seg faults, and it can give you guaranteed thread safety. Also, it's got modern language features that you can expect to see in the higher level application languages that you tend to use day to day as an application programmer. And it's got a really good embedded toolchain. So what I'd like to do now is give you sort of a whistle-stop tour of those things to give you a flavor for Rust. And so first, this is a really, really complex subject. It's going to be very difficult to get through in 10 minutes, so I'm not even going to approach talking about it. But Rust has this ownership model, which means that by default, memory is collected for you without using a garbage collector, and still gives you the control. But what you get is the compiler ensuring that your program cannot segfault. If you do something that would normally segfault, then the compiler is going to prevent you from doing that. Similarly, the compiler completely prevents you from breaking thread safety, which is huge if you're trying to think about a complex multi-threaded program. Next up, the embedded toolchain. Now, the embedded toolchain is this tool called Cargo. And Cargo was originally written primarily by Yehuda Katz. So it bakes in a lot of the things that we're used to from Bundler and through a lot of similar tools in higher level languages. And the great thing about Cargo is it manages the entire sort of application lifecycle. So to start off, you can call Cargo new, give your project a name. This flag at the end is actually saying make a binary. You can also make the project skeleton for a shared library as well. Once you've got that project skeleton, you open a file. You can provide some metadata, and you can and to add in any dependencies that you just add them in at the bottom. So then you'll open the main file. This is some code which I'm not going to attempt to explain, but if you want to have a look back through the posted notes, you can. This is basically a simple web server that responds with "Hello World." Once you've got your program, and that's literally all you need to do, Cargo run will fetch all of those dependencies manually. So unlike C, where you really have to do a lot of work to manage your dependencies, have to write manual make files, go and get dependencies and manually, Rust just pulls them down for you. And the place all of the dependencies are managed is in crates.io. This is the website for it. It's really, really similar to rubygems.org or NPM. It's got a really fast-growing amount of libraries, which are called crates. And these are all managed for you via Cargo. If you don't just want to run your code and you want to build a binary, then that's just as easy. If you run Cargo build, then it builds you a binary. And you can just run it from the command line. Additionally, it's got a built-in test runner. So if in your application code you write a function, you can actually add a test block within the same file, just denoted by the hash test part here, with tests in it, and then simply run Cargo test, and it's going to run all of the tests that are embedded in your suite, and also you can obviously put tests in separate test files if that's how you prefer to structure it. Next up, Cargo doc will create you some really, really nice documentation. As an example, this is some generated documentation for Iron, the web framework that we were using in the earlier example. It's got all the modern features you would like. It's based on Markdown. You can put Markdown sort of in comments directly in your code. You can add separate files of just Markdown and pulls it all together. And the really nice feature is that you can actually have Cargo test your code examples and verify that your code examples adhere to your real code and they still compile and run assertions correctly. Finally, I'll give you a whirlwind tour of some of the modern language features. We've got pattern matching via the match statement. This is all compiler checked, so the compiler will check if you're handling every instance. It's got closures in a really nice little neat syntax, which JavaScript is still struggling to get as neat as. We've got traits. Traits give a much more expressiveness to the type system and allow us to have generics which can be built on top. And there's absolutely loads more. It's a really, really nice language. So in summary, it's still really fast, comparable speed to C and C++. You still get that control. You've got safe memory, really nice modern language features, embedded toolchain. And all of this adds up to me as an application developer particularly, is it means that I can add the power of a systems language to my tool belt without having to resort to the sort of arcane craziness and non-safety of C and C++. The documentation site is great. rustlang.org, you can start there. When I post these slides, I'll add another slide at the end with like a reading list. There's loads of great talks and loads of ways to find out more about it. But thank you very much.